Okay, let me check to make sure. Now, suppose I bring that charged object. We've looked at how that would influence a conductor. Suppose I bring that close to an insulator. Well, on an insulator, the charge isn't free to move. So therefore, go ahead and make this 25.2 and 25.3 because the electric charge is not going to be able to be moved. I'm going to, as I bring this negatively charged object over, sure, if this were a conductor, it would drive away some of the negative charge on the side closest to the conductor, or have the effect of appearing to attract positive charge to that side. But in an insulator, that won't work. The best that you can do is if I look at each individual atom, let's say that I've got an atom with a positively charged nucleus, and then in the space around that positively charged nucleus, I've got a cloud of negatively charged electrons. The thing of that is, everything else being equal, the center of those electrons will be at the nucleus. So if I'm looking at this from any distance whatsoever, come walk over here, look at this, how are things going? Look over there, what do we see? A total charge of 0. But if I've got these negative charges, then I'll have then they'll stretch that cloud of electrons. The electrons won't be free to move, but here, the attractive charge, I'll get an attractive charge acting on the protons, and I'll get a repulsive charge acting on the electrons, but because the protons are a little bit closer than the electrons, and because the electric force depends on the distance between them squared, that means that the force on the closer object, that attractive force, is going to be a little bit more than the repulsive force, which means that the negatively charged object is going to feel an attractive force. Actually, it'll be equal to the difference between those two, but it will feel a force pulling them together. Now, under PhET physics, there is a useful display as that comes back up. If you look under physics, electricity, magnetism, and circuits, the very first one, balloons and static electricity, will show us, make sure that's fitting well. If I grab the balloon, okay, the balloon is neutral. So, where I move the balloon stays. there's no electric force anywhere because everybody's neutral. But if I take this balloon and I rub it on, say, the sweater, it'll pick up a lot of extra electrons, which means that the balloon, okay, now I've got opposite charges on the balloon and the sweater. So if I let go of the balloon, there's an attractive force pulling it toward the sweater. If I take the balloon and I bring it toward the wall, if you can see that, if you can't, go to PHET Physics and look, that as I bring the charged object near the wall, it's pushing away the electrons, and so there's a net attractive force. So if I bring it close and let it go, there's an attractive force.